All right, third question. So vector u for which the magnitude is equal to 1 is called, again, just another definition here. Anytime you have a vector that's just a length of 1, it's called a unit vector. Not too much to that one, or not much to that one. Okay, so this is moving back into stuff that we talked about in class. Plot the complex number in the plane 4 minus 4 root 3I, and then also write out the complex number in polar form. So just plotting it out, we have our horizontal distance, which is the real distance here, and then we have this the complex distance, the negative 4 root 3. So plotting it, we have a positive horizontal, negative vertical. It has to be A, right? To the right and then down. When it comes to finding the polar form of it, remember that means you're trying to find that R value and then that theta value. And these comes from the equations. So there's two different equations. X squared plus y squared equals R squared. That's how we're going to find the R. And then tangent of theta is equal to y over x. So just plugging it in, x squared plus y squared is going to be 4 squared plus 4 root 3 squared. And that is 16 plus 16 times 3, which is a number.
32 times 3, 16 times 6 is 64 times 2. No, 48 times 2. 96.
96, that seems too big.
32 times 3?
Just 6, no, remember you have to multiply first.
Oh. So 48 plus 16.
Yeah.
64.
64, that sounds better. And then the square root of that to get our R, so our R value is 8. And remember, that's the number that goes out in front for that polar form over here. Okay. Now we just have to find the angle. We get the angle by doing tangent of theta. And that's going to be equal to the y value 4 root 3. And then that divided by 4, which is just root 3. All right, so this is where you really need to be careful when finding the theta, and it all comes down to the unit circle. So let me find a unit circle here. Okay, so we're looking for where the tangent is root 3, but it has to be in the right quadrant. We already decided that our point was here in the 4th quadrant. In the 4th quadrant, tangent is equal to root 3 down here. Okay, so that's at, and we have to make sure we're in the right location, I guess. So I forgot if they wanted degrees. I think they wanted degrees, so 300 degrees. Let's just go back to the question and see what they were asking. Yeah, degrees.
The tangent is negative in that quadrant.
It is, yeah, and I think that's just because this should have been a negative 4 root 3 on top.
Oh, okay.
Yeah, negative 4 root 3 over 4. I missed my negative there. So back to the unit circle. Tangent is negative root 3 there at 300 degrees. Okay, and that's it. So yeah, sorry I messed that one up a little bit, but we get the R value of 8, and then we get our theta is 300 degrees for that complex number. Is that all right? Does that make sense?
Yeah.
Next question. All right, decompose V into two vectors V1 and V2, where V1 is parallel to W and V2 is orthogonal to W. So So we're given V and we're given W. So then what does V1 equal, and then what does V2 equal? Okay, so what we're doing here is that we're breaking down vector V into a vector in the direction of W and then a vector in the opposite direction of W. I know that question looks like kind of crazy looking, so let me kind of draw a picture of what they're asking you to do here. So if you have a vector V and then you have a vector W, let's say W is just going horizontally. What you can do to vector V is that you could break it up into two vectors. You could break it up into the vector that's going in the same direction as W and then a vector that is going in the orthogonal direction to W. You're basically making a triangle out of it.
Okay.
This makes a lot more sense when you're just doing horizontal and vertical. Like if you have a force vector, you can break up that force vector into the horizontal component of force and the vertical component of force. But it doesn't just have to be horizontal and vertical. It can be any vector. So let's say you did have maybe a vertical vector that was your V, and then your W is diagonal. What you can do is you can take your vertical vector V and you can break that up into something that's going in the direction of W and then something that is perpendicular or orthogonal in the opposite direction of W, where it makes a little right triangle there. So that's what we're doing. We're taking a vector and we're breaking it down into the triangle components in a certain direction. Okay. To do that, there's a formula, and that formula that we're doing is something called the shadow, but it's not the shadow in the book. What do they call it? I'm totally blanking on the name of it. I think I pulled up the book, didn't I? No, I didn't. Let me pull up the book real quick just so I can look up what this name is. We need the formula for it as well, and the formula is kind of complicated. Maybe we'll be able to pull up the book. There it goes. Come on, book. The one time my computer like freaks out on me. This is the one time I really need it.
Is that chapter 10, right?
Yeah, chapter 10, section 5. It has to do with that dot product stuff.
Scalar product. Edit. Angle between vectors.
No, not that either.
Vector projection of the U on the V or V on the W.
Yes, that's what we're trying to do. Vector projection. That was the name I was trying to think of. So the vector projection, that's that shadow thing that I was trying to say. You want to think of it like you're casting a shadow of one vector onto another. I'm just trying to get to it in the book here, because I know in the book it'll have a really nice picture of vector projection as well. All right, yeah, so here's the formula for it. And this is kind of the concept that I was talking about. So let me make it a little bit bigger. So here we have our vector V, and then this tiny little vector here is vector W. So what we want to do is we want to take vector V, and you want to think of it as if there's like a sun or a light source that's perpendicular to V out here, that's casting a shadow from V onto the direction of W. So this thing that we're casting is going to create a new vector here, V1. V1 is parallel to W because it's going in the same direction. It's just a little bit longer in this example. And we're also going to have another vector here, orthogonal to W, V2. It's these two things that we're trying to find as an answer. And to do that, you're just going to find the vector projection of V onto W using this formula. All right, so let me write out the formula here. It's going to be V1. Oh, crap, wrong button. It's all right. I'll just do it without making stuff bold. It's all right. So that V1 is going to be equal to the dot product divided by the magnitude. So dot product divided by the magnitude of W. All of that times just V. Or sorry, W, not V, because we want it in the direction of W. And this dot product should be up top. All right. So going back to the actual question that we had here with our V and our W, first thing that we need to do is we need to find that dot product. And there's just a formula for finding the dot product. The dot product is you multiply the horizontal components together plus you multiply the vertical components together. So for our example, we're going to multiply the -4 on the I of V times the 1 on the I of W, that plus the vertical component, -2 on V times the vertical component on W, 1. Just adding these together, we get -6. We also need to find the magnitude of W, and that's that square root thing. So this is going to be the square root of just W's components, 1 squared. Yeah, plus another 1 squared. Oop, that should all be under the square root. So we get the square root of 2. And then this W itself is just the vector. This is not a dot product. This is just actual multiplication. Because V dot W over the magnitude is a number, and you're multiplying a number times that vector. So we get V1 is going to be that -6 up top, divided by that square root 2, times vector W itself, which is the vector 1, 1. Then you just multiply that into it. So this is going to give us the vector -6 over square root 2, -6 over square root 2. Yeah.
Okay.
Okay. And so that is going to be V1, or it should be. Oh no, we made a mistake somewhere.
You didn't make a mistake. You didn't simplify it.
Well, these don't even have square roots in them over here.
Well, parallel would be.
I know what we didn't do. We didn't copy the the formula down right.
Oh, it's squared.
It should be squared there on the bottom.
Which would make it 2.
Yeah. So that should be squared. So these aren't square root 2's down here. There should be just 2's. Which is going to give us the vector then -3, -3. There we go. That's better. Because that was one of our answers. Okay, and so that's going to be the first vector. And then we just have to find the second vector. The second vector is just going to be what's left to get back to where V ends. And there's a formula for this one too here in the book, although I hope it's kind of obvious. To get V2, you just want to subtract V minus that new vector that you just got, V1. So V2 for us, pull back up the question, is going to be V minus V1, where V is the vector -4, -2, and I'm going to subtract from that V1, which is the vector -3, -3. Whenever you're subtracting these things, you just want to subtract component by component. So we're going to do negative 4, minus negative 3, which is negative 1, and then negative 2 minus negative 3, which is positive 1. Negative 1, positive 1 is going to be this vector here, negative I plus positive j. All right, cool. So yeah, that took us a while, but it just comes from the formula. So make sure you have this formula handy when you're going to take the test. This is the formula whenever you want to do a projection of one vector onto another for questions like this.
Okay.
All right, next question. More vector stuff. The vector v has initial point p and terminal point q. Write v in the form ai plus vj. That is, find its position vector. So there's a formula for this one as well, although I don't usually think of it as the formula. Whenever you're trying to find the vector that goes from one point to another, you just want to find the horizontal distance and the vertical distance. So here we have the point 10, 3, and then the point 4, 6. The initial point is P and the terminal point is Q. To get from 10 to 4, I have to go in the direction horizontally negative 6. Right, to get from 10 to 4, I have to go backwards 6 spaces.
Okay.
And then for the vertical, to get from 3 to 6, I have to go in the positive direction 3 spaces. So then this is my vector, negative 6i plus 3j. Okay. All right, more definition stuff. Complete the sentence below. If F1 and F2 are two forces simultaneously acting on an object, the vector sum F1 plus F2 is called the blank force. Again, just definitions there from the book. This is what's called the resultant force. The resultant force is adding two forces together. So just a straight definition. This was stuff that we did in class. Find ZW and Z divided by W. Leave your answers in polar form. So whenever you're given the polar form here, multiplying and dividing is very nicely. We don't even need to write this stuff out. When you multiply two complex numbers together, you just multiply their R values. So 4 times 10 is 40. And then you add the angles. So 140 plus 340 is 480. The problem with 480 is that it's too big, right? It's outside of the unit circle. But we can find the coterminal angle that's equal to 480 by subtracting 360.
So 120.
So 120 is going to go here. Same thing when doing the quotient. So to find the quotient, you want to divide. We are doing Z divided by W, so 4 divided by 10 is 2/5. And then 140 minus 340 is really negative 200, but that's not in the unit circle, so here we have to add 360. And adding 360 is 160. All right, and that's all there is to that. Does that make sense? Any questions about that one?
So for the multiplying, you just multiply the R, right? Is it R?
Yeah, that's the R's.
And then just add the angles.
Yep.
And for dividing, you divide and subtract.
That's all there is to it.
Okay.
Another definition thing here, complete the sentence below. If V equals A, B is a vector whose initial point is the origin, then V is called. So yeah, just straight up definition. This is what's called the position vector. So one thing about vectors that I haven't said so far is that vectors don't necessarily have a starting location. If I draw out just a normal regular vector, it could be anywhere on the XY plane. So maybe this vector is here. But if I take that vector and I move it so that it does start at the origin, then we call it a position vector. All right, so that's all that means. A position vector is one that starts at the origin and then points wherever it needs to point. Complete the sentence below. If P equals xy is a point on the terminal side of the angle theta at a distance r from the origin, then tangent is blank.
Mr. Leeser, hold on a second. Live video is not catching up.
Oh, okay.
I'm gonna dial right back in.
Okay.
There we go. Now it's caught up.
You back?
Yep.
Okay. So if P equals xy is a point on the terminal side of the angle theta at a distance r from the origin, then tangent of theta is equal to something. I think they just want the straight up like definition for tangent of theta.
Y over x, right?
Yeah, so just y over x I think is all we need to put in there. Okay. All right, so another one of these, find ZW and Z divided by W, and then you're given Z and W in rectangular form, but they want the products in polar form. So we're just gonna have to do a little bit of work first by transferring these over to their polar form. For Z, which is 8 minus 8i, if I want to change that into polar form, first I have to do the formulas, right? X squared plus y squared is equal to r squared. And then the other formula, tangent of theta, is equal to y over x. So for the first one, that's going to be 8 squared plus 8 squared is equal to, so that's 64 plus 64, which is 128, but we could rewrite that as 8 square root 2 after we take the square root. So we're going to get r is 8 square root 2. Okay. For the tangent, right, that's going to be tangent of theta. It's going to be equal to the y value negative 8 divided by the x value positive 8, which is negative 1. You have to make sure we're in the right quadrant again. So we go over a horizontal distance that's positive, a negative vertical distance. We're in quadrant 4. And in quadrant 4, tangent is negative 1 at the degrees, is it 345? No, 315?
Yeah.
See if I think I clicked off my unit circle. Yeah, it's kind of hard to see, but yeah, there 315 degrees is where my tangent is negative 1. Okay. All right, so that's Z, and now we have to do the other one. So for W, I have the square root of 3 minus I. Again, finding the R and the X, so we're going to do the square root of 3 squared plus negative 1 squared. That comes out to be 4, which says that my R value has to be 2. We're also going to do tangent of theta is going to be equal to the y divided by the x, which is going to be negative 1 divided by square root 3. This is also in the fourth quadrant, right? Positive x, negative y. And in the fourth quadrant, tangent is negative 1 over root 3 here. See if I can make that a little bit bigger.
And 330, right?
It should be 330, yeah. Yeah, here at 330. Okay, and then remember that we are multiplying and then dividing. So just to write out the two things that we have now, we have Z is going to be 8 square root 2 times cosine plus I sine of 315 degrees. W is just 2 cosine plus I sine of 300 degrees. So then z times w is going to be multiplying the two r values together. 8 root 2 times 2 is 16 root 2. And then cosine plus I sine, adding the two degrees together, we get 615. But we can fix that. 615 minus 360, I think is 245.
Sounds right.
And then z divided by w, very similar. We're going to divide the r values, which would be 4 root 2. And then subtracting the angles, 315 minus 300 is just 15.
You say 255?
Is it 255?
Yep.
Okay. So here we get the 16 square root 2 and then 255 for the cosine and the sine. The quotient was 4 root 2 and then just 15. Cool. Yeah, so a little bit more work for that one, but still fairly nice answers. All right, next question. Write the expression in the standard form a plus bi, and we have root 5 plus I to the 6th power. All right, what you do not want to do is you do not want to multiply this thing out 6 times as is. So first we're going to change the polar form. So we're given this square root 5 plus I. Same formulas as before, x squared plus y squared is equal to r squared. I'll go ahead and do that one. That's going to be the square root of 5 squared plus 1 squared. That's just 6, which means that my r is just the square root of 6. Okay. And then for the theta, we do tangent of theta is equal to the y divided by the x, which is going to be 1 over the square root of 5. That's not a nice number, which is why here in the homework it says to round to the nearest thousandth. So this is where you're going to have to use the calculator. So in the calculator, you have to do tangent inverse of 1 over root 5 to get a thing. And I just realized that I don't have any calculator within reach. Do you have one with you?
I don't have my, let me see if my phone's got it on there.
Okay.
I don't have tan inverse.
All right, let's see if the internet can save us. Tan inverse of 1 over square root 5. Not really. Oh no. Alright, we'll just pretend. Pretend that you get an angle coming out of that. Alright, so whatever that angle is, then you're going to write it in that other form. So the other form is going to be the r value out in front, which is square root 6, times cosine plus I sine of whatever this angle was that you just got from here. And we're going to take that and raise it to the 6th power. Raising it to the 6th power just means you're multiplying it by itself 6 times. Root 6 to the 6th power is going to be out in front. And then cosine plus I sine of whatever that angle was up top times 6. Root 6 to the 6th power is the same thing as just 6 cubed. Because square root is the same thing as raising it to the 1/2 power. So raising it to the 1/2 and then raising it to the 6th, all in all, is the same thing as cubing. All right, and then we're pretty much done at this point. It's just that we don't know what that angle is. So this is why it says to round. You would just plug in whatever the angle is times 6, and then do cosine of it plus sine of it, and figure out what it has to be. Okay, we'll have to skip that one since we don't have a calculator. Was the process all right? Any questions about the process there? You still with me, Jason?
Sorry, I was muted.
Oh, okay.
Yeah, that makes sense.
Okay. Moving on. Next question then. We'll just do like a few more of these and just get out of here if that's all right with you.
Yeah, that's fine.
For the following vectors, find the dot product, find the angle between in the state where the vectors are parallel, orthogonal, or neither. So just real quick, the dot product. Remember the dot product is you multiply the horizontals plus you multiply the verticals. So V dot W, multiplying the horizontals together, we're going to do 3 times negative 9 plus the verticals together 4 times negative 12. So that's what, negative 27 minus 48, which is negative 75. Okay, so that goes here. Then it's asking for the angle between, and then there's just a formula for that. So the angle between two vectors, let me go back to the book here. It's very similar to the way that we were doing the projection. The formula is just slightly different. And you're going to have to do I think it's a sine inverse to get to it. Here. So cosine of theta is the dot product of the two vectors divided by the magnitude of the two vectors. So I'll just copy that down over here. Another way of thinking about that is that cosine is going to be, the angle is going to be cosine inverse of that other side, where that other side is the dot product of the two vectors divided by the magnitude of the two vectors. Okay, so let's just do these separately. We already did the dot product up top there. That came out to be the negative 75. But we are going to have to do the magnitude of the two vectors. The magnitude of V is going to be the square root of the components squared together. So 3 squared plus 4 squared. That'll all come out to be 5 in the end.
Yeah, that's 25.
And then the magnitude of W is going to be the square root of 9 squared plus 12 squared. I don't think this comes out to be a nice one. So what is it? Sorry?
225.
225? I guess it is a nice one. I think the square root's 15.
Yes.
Okay, so then that's pretty much it. So plugging it back into the formula, theta is going to be the cosine inverse of, remember that numerator was negative 75, and that's going to be divided by 5 times 15. 75 divided by that stuff,
1.
it's just negative 1. And then cosine inverse of negative 1, that is at 180 degrees. So the angle between these two vectors is 180 degrees. If you have two vectors where the angle between them is 180 degrees, they're going to be parallel vectors. So if one's going this way and the other one is going the exact opposite way, these two lines that they make are parallel to one another. Great. Does that make sense? Is that all right? Parallel?
It does.
Cool.
Yep, that one makes sense.
All right. The next one here. We did one similar to this before. The vector V has initial point P and Q. So it's just going from P to Q. To go from negative 4 to positive 5, I have to go 9 units in the positive direction.
9, 5.
And then, so from negative 8 to negative 3, 5 units in the positive direction. Okay. Complete the sentence below. If V is equal to 3W, then the two vectors are, these are going to be parallel again.
Parallel.
Yep. So all 3W is just V, but 3 times as long, but they're still going in the same direction. Let's just do maybe one more. Find the direction angle of V for the following vector. And when it says the direction angle, It's just talking about the theta that you would get if you switch this over into the polar form. So that's coming from that formula. Tangent of theta is y divided by x. So for this question, tangent of theta would come out to be the y value 10 divided by the x value negative 10 square root 3. Which is just negative 1 over the square root 3. And then again, we would just have to find the angle in the right quadrant. This time we're going in the negative horizontal and the positive vertical, so we're in quadrant 2. And again, I think I got rid of my unicircles again. So in quadrant 2, tangent is negative root 3 here. This is at 120 degrees.
Yep.
So that says that the direction angle has to be 120.
Perfect.
Okay, cool. Yeah, so I hope that helps.
Something to do this for us.
Well,
Or at least for me, anyway.
Good, yeah. Yeah, that was a lot of questions from the stuff that we did not have time to cover in class before we were kicked out.
Yeah, that's a lot of what I was really confused about.
Well, that's good.
Works.
Okay. Well,
Appreciate it.
yeah, thanks for coming.
You have a good one.
Yeah, and good luck on the test.
All right, thanks.
Mm-hmm.
Bye.
Bye.